Hello viewers, in today's class we are going to discuss one important and conceptual problem from limits, right? And here we have to find the value of this limit, that is limit x tends to 2 plus signum of x divided by 1 plus greatest integer of x minus 1, right? And here the positive sign shows that we have to find the right hand limit of this function, right? So here we have x is equal to 2 and we have to approach towards 2, that is x is equal to 2 from the right of x is equal to 2, right? So here let us first call this limit as L. Now in order to evaluate this limit, let us substitute x is equal to 2 plus h, right? We are taking x is equal to 2 plus h because we have to find the right hand limit of this function when x approaches towards x is equal to 2, right? And here h is a positive quantity and h is a very small quantity, right? So when x tends to 2, obviously h tends to 0, right? So now this limit L can now be written as limit h tends to 0 because when x tends to 2, h tends to 0, right? So we have limit h tends to 0, signum of here we have signum of 2 plus h, right? Because here we'll replace x by 2 plus h, right? And in the denominator we have 1 plus x greatest integer of x minus 1, so x is 2 plus h minus 1, right? So now we can write it as limit h tends to 0, this is signum of 2 plus h, and in the denominator we have 1 plus this is 2 minus 1 1, so this is 1 plus h, right? Okay, so now let us first decide the value of this greatest integer of 1 plus h, right? Now see, 1 plus h is slightly greater than 1 but it is less than 2, right? Because h is a positive quantity, that is h is greater than 0. So 1 plus h is always, it is slightly greater than 1 but less than 2. So by definition of greatest integer function, the value of greatest integer of 1 plus h is equal to 1, right? So here we can take 1. So now this limit is limit h tends to 0, signum of 2 plus h, and here we have 1 plus 1, that is 2, right? So this is limit h tends to 0, signum of 2 plus h, and here we have 2, right? So now viewers, here now we have to decide the value of this expression which is in the numerator, that is signum of 2 plus h when h tends to 0, right? Now here we'll take help of the definition of signum function, right? So signum of y, let us take some variable y. So signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than 0, right? So this definition is used to decide the value of this expression, right? So if we take y is equal to say 2 plus h, right? So here we have signum of 2 plus h. So if we take y is equal to 2 plus h, and we already know that h is a positive quantity, that is h is greater than 0, so 2 plus h is obviously greater than 0, right? And see, when y is greater than 0, then signum of y takes the value plus 1, right? So therefore signum of 2 plus h is equal to plus 1, right? Because 2 plus h is greater than 0, and whenever this variable, that is here we have y, so here for y we have 2 plus h, so whenever 2 plus h is greater than 0, then signum of 2 plus h is equal to plus 1, right? Because h is positive quantity, that is h is greater than 0, 2 is positive, so 2 plus h is positive, right? Okay, so now this limit L is limit h tends to 0. Now we have signum of plus 1, right? Because for this term we have plus 1 value, right? And in the denominator we have 2, right? So now this is this limit is now equal to signum of 1 over 2, because here we do not have any term involving h, right? So the limit is now equal to signum of 1 over 2. Now let us see the value of signum of 1. Now see, here we have signum of 1, and this 1 is obviously greater than 0, right? Because 1 is positive, so 1 is greater than 0. So therefore again by this definition signum of y is plus 1 whenever y is greater than 0. So therefore signum of 1 is equal to 1, right? So here we have now 1, and here we have 2, right? So viewers, the value of this limit is equal to 1 over 2.